This is section 1.4. We're going to evaluate expressions with variables and also identify something as a solution or not. So a letter is a variable is a letter that's used to represent one or more numbers. We use letters like x, y, t. The most popular one is x. Don't confuse that with an operation or multiplication. We can also use Greek letters. Variable expression, that's a collection of numbers, variables, and operations put together. Like here is one expression right here. Here is another one. Here is another one. Here is another one. Go Packers. Just kidding. Go Vikings. Just kidding. I'll play it safe. There's my highlighter. So there's 4 different expressions here. Evaluate the expression by replacing each variable with the expression, replacing each variable in the expression with a number. Let me use my fancy pen here. So if x equals -3, evaluate 6 times x times 2. So let's substitute that in. 6 times -3 times 2. So we get -18 times 2, which is -36. Evaluate the expression if y equals 9, what's 3 times y minus 4? So that's 3 times 9 minus 4. It's 27 minus 4, that's 23. Boom. This is my fancy pen. We can substitute in multiple letters or multiple numbers for multiple variables. So that came out kind of wrong here. But in other words, we're going to do our substitution here. So let x equal 4 and let y equal -3. So we have 2 times x plus 4 times y. So we have 2 times 4 plus 4 times -3. Make sure you follow your order of operations. We have to multiply here first. So multiplying here, multiplying there, and then we add together. So -4. Let p equal -6 and r equal 2. So evaluate -3 times p times r. So -3 times -6 times 2, which would be 18 times 2, which is 36. So that's the idea here. You can go ahead and pause it and race me through and just check your answer here on this next one. So we're going to multiply 5 times, I'm going to put parentheses in here. Shoot. 5 times 7 is 35. And then here we're subtracting. We got 35 minus -1. Now instead of subtracting, I like to add the opposite or keep switch flip. So I keep the 35, I flip the subtraction to addition. So I'm adding. Then I need to flip the sign of the second number, which really turns it into the opposite in this case, which is adding. So we get, or positive, so we get 36. There we are. Last one. Get my fancy pen back. That's probably why I'm stumbling. Y times y minus 3 times z. So y is 7 minus 3 times z is 3. So I plug in 3 for z. So here I have to multiply first. So I get 9. 7 minus 9. That's -2. So yes, folks, if you're wondering why I'm doing what I'm doing, refer back to PEMDAS. This is the order we have to simplify things from top down. So here's the new test that we're looking at. How do I know if a value is a solution to an equation or an inequality? So an equation is 2 expressions with an equal sign between them, and they truly should be equal. So I'm wondering if 3 is a solution to this equation. Does 3 actually, when I simplify this left side, does it actually equal 7? Well, so I'm going to substitute and simplify and then analyze. So I'm going to substitute in 3 for x. So 3 times 3 minus 2. Does that equal 7? Question mark. I don't know if it's actually equal. Well, 3 times 3 is 9, and 9 minus 2 is 7. So does 7 equal 7? Yes. So then we're going to say, yes, 3 was the solution. 3 was the magic number that when I plug it in for x, it works. Yes, 3 is the solution. Let's try this one over here. Ooh, now I'm wondering, when I plug in -1 for x, so it's 4 times -1 minus 5, does that equal question mark x plus 3? Well, wait a minute, remember x is -1, so does it equal -1 plus 3? So now we need to simplify the left and the right side. So we need to multiply first before we subtract. So I'm just going to do the left side first. So the left side I get -4 minus 5, which is -9. On the right side I get 2. Does -9 equal 2? No. So what was I wondering, what number was I wondering if it was a solution? -1, I was wondering if it was a solution. Is -1 a solution? So no, -1 is not a solution in this problem. Lastly, we have inequalities here. So remember, Pac-Man eats the bigger number, right? Or let's see, you guys do Pac-Man's, alligators. There's some other symbols I've heard students think of. When you see this symbol, how do you this number should be bigger and this number should be smaller. If it's actually a true inequality, or if it's going that way, this number should be big and that number should be smaller. So let's substitute in, they're wondering if -2 is the solution to the inequality, so let's substitute -2 in place of x. So 3 times -2 minus 4, is that actually greater than 5? So use your order of operations, -6, multiply first, and then subtract 4, we get -10 on the left. Is that greater than 5? No. So that means -2 is not a solution. Example number 7, is 4 a solution to this inequality? So let's go 2 times 4 minus 3. Is that less than or equal to 9? So we get 8 minus 3. I'm putting a question mark above this just to make sure I'm remembering that this might not actually make sense. 8 minus 3, is that less than or equal to 9? We get 5. Is 5 less than or equal to 9? Yes, it is. So what number were we checking to see if it was a solution? 4. 4 works. It makes a truthful statement, so 4 is a solution.